So my lab was part of this multi-institutional project called FIREX. It was a project sponsored by NASA and NOAA to understand emissions from wildfires in the real world. It was a 5-year-long project, and we were really trying to understand emissions in actual wildfires from the ground level all the way up to the troposphere and to the stratosphere. There were flights which were sampling plumes from real world fires in the western United States at an altitude of 10 to 12 kilometers, and synchronized with it was ground based measurements using a mobile van, the physical properties, the optical properties of the smoke, and we were literally chasing fires. What happened was that study was the starting point of our discoveries which unfolded. The take home was that the conventional wisdom which prevailed up until then was that black carbon or soot was the major black or the darkening pollutant from all these wildfires. So what we found was that it was not the soot which was causing the darkness, it was organic carbon. So organics are co-emitted along with this black carbon or soot, and so we term these particles as dark brown carbon. So when you see a smoke plume coming in, it's usually like brownish haze, right? What we think now is that these brownish haze is constituted predominantly by this brown organics, shown with evidence in real world fire plumes that this is a species which policymakers and the climate modelers and the IPCC, a panel on climate change, need to take into consideration Earth's energy balance from events such as wildfires, which is increasing rapidly every year, and further what is the health impacts of these plumes when they make it to a urban area. We will be inhaling it. So how toxic are these particles? So these are a lot of unknowns there, because nobody has looked into the toxicity of these dark brown carbon particles which we reported. So one of the steps what we have taken is, in my lab we are now trying to generate or synthesize this class of particles using a simple laboratory bench scale setup. These particles, they do not bleach. These particles were expected to fade, but what we found using aircraft measurements is that they do not fade, meaning they retain their strong light absorbing nature or their brownness or their darkness even over a period of 7 to 10 days. So if a plume, say from Canada, makes it to St. Louis, we can be certain that that plume will probably constitute a significant fraction of these particular class of particles. So which will not only perturb the local environment and the temperature, but also could have health effects which we do not know about. So these particles are less than a micrometer. A micrometer is 1,000 times smaller than the thickness of a human hair. Once inhaled, they can get deposited into the deep portion of human lung. So what happens once we inhale this smoke particles? Say if you have an onslaught of smoke plumes hovering over cities like we had the last 2 summers. What happened from the Canadian wildfires, right? We had smoke influx. The plumes made it to St. Louis. So once you're inhaling, what happens? What my lab is trying to mimic is the co-production of these dark brown carbon particles along with soot or black carbon from wood chips, any biomass burning fuel. That's a process which takes place in the very early stages of a fire when the temperatures are really hot. When you have the flaming phase of a fire, you find this, and that's what is being mimicked here. So we are right now doing toxicology studies to look at these particles, the effects on the human lungs, as well as we are trying to see if people who have had chronic exposure to this smoke plumes or particles and they live in areas where wildfires is a very frequent event, could there be a connection between exposure to these particles and onset of Alzheimer's? So the toxicity side of things connected to inhalation of these particles is something which we are investigating. Down to the particle level, what we find is that these particles, they are insoluble in a liquid medium. So, when they are inhaled, they most likely do not dissolve in the human lung, and so they remain in the particulate state, and then these particles, they provide surfaces for reaction chemistry to take place. What we are trying to investigate is that what is the oxidative potential of these particles. So, oxidative potential is a health metric which directly connects the toxicity of a particle and what impact could it have in human health.